So solving 3D trig problems. Now, when solving these problems, there's just pretty much a checklist that you need to go through to solve these problems. So 3D problems are referring to the fact that the situation that you are answering these questions is 3D, but when you are actually doing the trig is still in two dimensions. Like you're still doing you're still doing 2D triangles, but the situation they're in is 3D. So this is the list of all the things that you need to do. So number 1 is draw a diagram marking all right angles. Okay, then 2 is a simplified diagram, and 2 and 3 are sort of linked together. Identify all triangles. So try and draw your triangles out that you can see in your 3D shape in all the two-dimensional aspects and all individually. And then go around and solve all the triangles until all information that you need is found. So that might mean that you have to use one triangle to actually find part of another triangle. Now there is a step 5 as well, which is if no triangle can be found, assign a pronumeral to what is to be found, then work around the diagram until the equation in that pronumeral can be formed. So as in, like, if you can't find something, then use what you want to find and put a pronumeral there. We'll be seeing an example of that though in a later video. Okay, so that's our checklist. Let's do a problem. So Anne, Billy, and Catherine were sitting at point O. Okay, so if we have a look at this picture over here, there's point O, it's in the middle. Billy states that he can run faster than Catherine, and to test this, Anne travels to the very top of the building, or a building. Okay, so up the top. So she's on top of the building there. Okay. They both, so Billy and Catherine then begin running at the same time. Billy runs due west. Okay, so he runs due west, and Catherine runs due south. So as you can see over in the diagram, west is where Billy's gone, south is where Catherine's gone. Now it's not exactly exact, but I mean, when you're drawing these problems out, it doesn't actually matter which direction you have them, but you just need to make sure that the direction is pretty straightforward. But we know though that between those two it should be 90 degrees because there's 90 degrees between south and west. Okay, they both stop at the same time. Billy stops at point B, so that point there. Okay, so Billy stops at point B. Catherine stops at point C, that one there. Billy now sees Anne at an angle of elevation of 61 degrees, while Catherine sees Anne at an elevation of 59 degrees. Okay, so that is that the angle between Billy and Anne is 61 degrees, and for Catherine it is equal to 59. Now the question is, who is quicker? Okay, so we've got some triangles that we can work with. Okay, so let's start off with one of the triangles. And it's going to be the Anne and Billy triangle. So over here, okay, so Anne's on top of a tower that is at O, that is 400 meters tall. It's a pretty tall tower. So 400 meter tall tower. Okay, Billy has ran out to here, and then he looks up at Anne, and it is 61 degrees. Okay, so that's that triangle there. But now our other triangle, and these are right angle triangles by the way, and our other triangle is that Anne's on top. It's 400 on the top of the 400 meter tower. Okay, so there's the base, and then Catherine ran out here. When she looks back, she looks up at a angle of 59 degrees. Okay, so who's faster? Now the easiest way to do this is to work out what this is equal to and what this is equal to. So x and y, and that will tell us who's run the furthest, because that distance there, so whichever distance is bigger, is the person who ran the furthest. So we'll start off with x, or with Billy, I should say. So let's go with, so we need to use tan for this one because it's opposite and adjacent. So tan of 61 degrees is equal to the opposite, which is 400 over x. Okay, so to get the x by itself, we're going to swap the x and the tan 61 degrees around. Okay, and so putting that into our calculator, we get 222 meters. Okay, so that's that one done. Okay, now we're going to do Catherine. So same thing, opposite adjacent, it's tan again. So this time it's tan 59 degrees is equal to the opposite, which is 400 over y this time. To get the y by itself, we just swap them around. So 400 over tan 59 degrees. So y is equal to, put into calculator, and we get 240 meters. Okay. Now, because it's a 3D trig problem and it's a problem, we have to write a sentence. Therefore, Catherine, God, I can't even spell. Catherine is the quicker person. And then as she ran further. And that'll do. Okay. So there's our first example done of a 3D trig problem. So most of them are like that. Just draw out your triangles, use your regular trig ratios and stuff, and solve it for those. Okay, I'll see you guys in the next one.